Hi students, in this video we're going to look at how to solve equations involving fractions. So what we want to be able to do is solve equations that involve fractions where the variable is either in the numerator or the denominator. Okay, so big things to remember are that 2 over x is the same as saying 2 divided by x. That will become quite important when it comes to rearranging. And then remember how to solve equations. We need to apply our order of operations but in reverse, then use inverse operations to create equivalent equations, and that helps us do our solving. So for example, when we have 3x minus 5, we need to move the minus 5 first. We move add and subtract first by adding 5 to both sides. And then to get rid of that 3 times x out the front, we're going to divide by 3, and that gives us our final answer of x equals 3. All right, so we're just going to get into it and do a couple of examples, and then just talk through some of the specifics about each example as we go. So for this first one, pretty straightforward. We've got an x divided by 4 here and a plus 1. The first step we have to remove is the plus 1. So we're going to subtract 1 from both sides. X over 4 is going to equal 2. And then to get to our next line, we've got x divided by 4 here. So to counteract that, we're going to multiply both sides by 4. And so we're going to get x equals 8. And there's our solution for our first one. Not too challenging. Now for our second one here, we've got x plus 6 over 3 minus 8 equals negative 2. Now in this case, students, key thing to remember is that above this, we call it the vinculum line, this in our numerator, there are brackets written in there. We just don't usually write them in. That's just not how we express our fractions when it comes to algebra. So we can't touch that 6 until we remove everything else, the minus 8 and the divide by 3. So if you need to put the brackets in so you remember, write them in and know not to touch the 6 until you moved everything else. If you don't need them, you don't need them. But just a reminder, we can't touch that 6 until we remove everything else. So our first step here is going to be plus 8 to both sides. So x plus 6 over 3 is going to equal negative 2 plus 8 is 6. Next step will be multiplying both sides by 3. X plus 6 equals 18. And now we can get to that 6, and now we can subtract it. X is going to equal 12. Doing our equation that way. So with that second example, make sure you remember we can't touch the numerator. We can't break it apart. We can't deal with that 6 until we move everything else first. All right, in this next one now, this one's a bit different as well because this time we've got x in our denominator. So I'm just going to start off solving. First step will be to add 3 to both sides. So 20 over x equals 5. 2 plus 3 is 5. Now, my step here is going to be multiplying both sides by x. When I multiply both sides by x, it'll be divide by x and multiply by x. Those are opposites. That's going to equal 1. And so it'll be 20 times 1, which gives us 20. And then on the right side, we're going to have 5x. And then to rearrange that 5, once again, we can just divide both sides by 5. And so 4 equals x. If you like switching them around, remember you can switch the sides of your equation around. That's totally okay too. And so x equals 4. So one to watch out for there, when x is in a denominator, you can multiply both sides by that denominator. And now we no longer have a fraction, which is what we want. Okay, this next one. Okay, we have 2 fractions now. What we should do in this case is combine those fractions together. So remember, when we go back to adding and subtracting fractions, they need to have the same denominator. So this left fraction, I'm going to multiply top and bottom by 3 to get a denominator of 12. This second fraction, I'm going to multiply top and bottom by 4 to get a denominator of 12 as well. So rewriting that, that will become 3x over 3x over 12 minus 2 times 4 gives me 8x over 12, and that equals -3. Now I can combine these terms together. They've both got a denominator of 12, that's great. And then 3x minus 8x, so those are like terms. So 3x minus 8x is going to be -5x. That equals -3. And now we can just multiply, do our usual solving steps from there. We've got to divide by 12 here, so we can times both sides by 12. And get -5x equals -36. And then finally divide both sides by -5. So x is going to be -36 over -5. A negative divided by a negative is just going to be a positive. So as a fraction, my answer is 36 over 5. Students, don't forget, if you do have a fractional answer, you can leave it as a fraction. That's totally okay, especially if the question doesn't specify. Just make sure you simplify your fraction. In this case, 36 over 5 can't be simplified, so that's a perfectly good answer. All right, this last one, 48 over x minus 3 equals 8. Now, again, this one's a little bit different because in our previous examples, we had x on its own on the bottom, not x minus 3. So what are we going to do here? Remember that we do have brackets around here, so that our vinculum line, our fraction line, means we can't touch the bottom until we deal with the other numbers, or it means we've got brackets around there. Now what we're going to do in this case is still multiply both sides by the denominator, but make sure you keep your brackets in there. So when we do that, divide by x minus 3 and times by x minus 3 are opposites. So x minus 3 divided by x minus 3 is 1, so that'll be 48 times 1, which will be 48. And that's going to equal 8x minus 3. Now from here, we can expand these brackets. So 48 is going to equal 8 times x, which will be 8x. And then we can do 8 times 3, which is 24. Rearranging that, we can plus 24 to both sides. Plus 24. 72 equals 8x. Then divide both sides by 8. 9 equals x. And there's our solution. There is another way you could rearrange this equation from this step here. Why don't you try and work it out and think about what you could do differently and still get to the same answer. Alright, so after watching this video, students, you should be able to solve equations involving fractions where variables are in the numerator or possibly even in the denominator too.